Good morning students. In this video I am going to explain you hybridization of inorganic molecules. So if the quotient is 2, so that is sp hybridization. So sp means one s orbital, one p orbital involved. So if the quotient is 3, sp2 orbitals, one s orbital and 2 p orbitals. Totally 3 orbitals are involved in this hybridization. If the quotient is 4, sp3, 5, sp3d, 6, sp3d2, 7, sp3d3. For example, water. Water formula H2O. In this water molecule, central atom is oxygen. So oxygen belongs to 6A group element. So valence is 6. So valence is 6 and 2 hydrogens. So 6 plus 2, 8. So 8 divided by 2, we get the quotient 4. So that is sp3 hybridization. So next example, ammonia. Ammonia formula NH3. So nitrogen belongs to 50A group element. So 5 plus 3 hydrogens. So totally 8 divided by 2. So we get the 4 quotient. So sp3 hybridization. So trichlorophosphorus. Trichlorophosphorus PCl3. So phosphorus belongs to 50A group element. 5 plus 3 chlorines 8 by 2. We get the 4 quotients sp3 hybridization. Fourth example, phosphorus pentachloride. Phosphorus pentachloride. So phosphorus belongs to 50A group element. 5 plus 5 chlorine atoms. So 5 plus 5 10 divided by 2. We get the quotient 5 sp3d hybridization. So next example, sulfur tetrafluoride. Sulfur tetrafluoride. So sulfur belongs to 60A group element. 6 plus valence is 6 plus 4 fluoride atoms. So total 10 by 2 divided by 2. So we get the quotient 5 sp3d hybridization. Next example, sulfur hexafluoride. Sulfur hexafluoride. In this molecule, sulfur is a central atom. So sulfur valence is 6. Sulfur belongs to 60A group element. So sulfur valence is 6 plus 6 fluorides. Okay, 6 plus 6, 12. So 12 divided by 2, we get the quotient 6. That means sp3d2 hybridization. sp3d2 hybridization. So next example, phosphorus oxychloride. Phosphorus oxychloride. So in this molecule, phosphorus is a central atom. So phosphorus belongs to 50A group element. So valence is 5 plus 3 chlorine atom. So in this molecule, so observe, so oxygen valency does not consider. Why? Because oxygen is a divalent atom. So that's why we should not consider the oxygen valency. We neglect the oxygen valency. That's why phosphorus valency 5 plus only chlorine 3. Okay. So 5 plus 3, 8 by 2. We get the quotient 4. So that means sp3 hybridization. So next example, thionyl chloride. So thionyl chloride formula. So SOCl2. So sulfur valency 6 plus, so we should not consider oxygen valency. We neglect the oxygen valency. So we take 2. So chlorines, 2 atoms are present here. So 6 plus 2, 8. 8 divided by 2, we get the quotient 4. That means sp3 hybridization. Next example, tin chloride or stannous chloride, SnCl2 formula. So tin chloride or stannous chloride, SnCl2. So tins belongs to 4th group element. So that is 4. That's why valency is 4. 4 plus 2 chlorine atoms. So totally 6 divided by 2. We get the quotient 3 sp2 hybridization. Lead chloride PbCl2. So lead belongs to 4th group element. So valency is 4 plus 2 chlorine atoms. So 4 plus 2, 6 by 2. We get the quotient 3. That means sp2 hybridization. So next example, aluminium trichloride. Aluminium trichloride. Aluminium belongs to third A group element. So valency is 3 plus 3 chlorine atoms. So 6 by 2, we get the quotient 3 means sp2 hybridization. Next example, sulfur dioxide. Sulfur SO2, sulfur dioxide. So in this sulfur having central atom, so sulfur valency is 6. So 6 divided by 2. Here oxygen valency does not consider. Oxygen is a bivalent atom. So that's why we neglect the oxygen valency. We should take only sulfur valency. So sulfur valency divided by 2, we get the quotient 3. So that means sp2 hybridization. So next sulfur trioxide. SO3, sulfur trioxide. Here also same. So we take the valency of sulfur 6 divided by 2. We neglect the oxygen valency. So 6 divided by 2, we get the quotient 3. That means sp2 hybridization. So next example, iodine monochloride. Iodine monochloride. So in this molecule, iodine is a 7th A group element. So valency is 7 plus 1 chlorine atom. 7 plus 1, 8. Divided by 2, we get the quotient 4. So that means sp3 hybridization. Next example, chlorine trifluoride. Formula chlorine ClF3. So chlorine belongs to 7th A group element. Valency is 7 plus 3 chlorine atoms. 7 plus 3, 10. Divided by 2, we get the quotient 5. That means sp3d hybridization. So next example, bromine pentafluoride. Formula BrF5. Bromine pentafluoride. So bromine belongs to 7th A group. 7 plus 5 fluorine atoms. So 7 plus 5, 12. Divided by 2, we get the quotient 6. That means sp3d hybridization. So next example, xenon difluoride. Formula XeF2. Xenon difluoride. So xenon is 8th A group element or 0 group element. So valency is 6. So valency is 8 plus 2 fluorine atoms. 8 plus 2, 10. Divided by 2, we get the quotient 5. So sp3d hybridization. Next example, 18th example, xenon tetrafluoride. Formula XeF4. Xenon tetrafluoride. So xenon valency is 8 plus 4 fluorine atoms. 8 plus 4, 12. So 12 divided by 2, we get the quotient 6 means sp3d2 hybridization. In this molecule, xenon having sp3d2 hybridization having. So next example, xenon hexafluoride. Xenon hexafluoride. Formula XeF6. So xenon valency 6 plus 6 fluorine atoms. 8 plus 6, 14. Divided by 4. Divided by 2, we get the quotient 7. So that means sp3d3 hybridization. So in this xenon hexafluoride, xenon having sp3d3 hybridization. So next example, xenon trioxide. XeO3. Xenon trioxide. And xenon tetraoxide. XeF4. Both are having sp3 hybridations. Why? Because here we take only valency of xenon. So we should not take oxygen valency. That why? Because this is a bivalency oxygen atom. So that's why 8 divided by 2, we get the quotient 4. So that means sp3 hybridization. In XeO3 and XeO4, both are xenon having sp3 hybridization. Next example, xenon oxy difluoride. XeOF2. Xenon oxy difluoride and xenon dioxidifluoride. Formula XeO2F2. Xenon dioxidifluoride. In both molecules, xenon having sp3d hybridization. So valency is 8 and we neglect the oxygen valency and 2 fluorine atoms. 8 plus 2, 10 divided by 2, we get the quotient 5, means sp3d hybridization. Both are molecule. So next example of xenon oxy tetrafluoride. XeO4, xenon oxy tetrafluoride formula. So xenon valency is 8 plus 4 fluorine atoms. 8 plus 4, 12. We get the 6 quotient sp3d2 hybridization.